All right, here we are on to the next session. The next session here we have is discussing cold storage as it applies to Ceph. And it looks like we have a couple of guys here that propose the blueprints, Matthias and Marcel. And so one of you guys wants to give us a little bit of an overview of what you were thinking here, and we can take it from there.
Sure. Hello. So I hope you hear me. This is
sounds
working
good.
Perfect. So first, hello from Germany. So I'm Matthias Grawinkel. I'm from the University of Mainz, and my colleague Marcel Lauhoff from my former University of Paderborn. And we are still looking at Ceph from a more or less scientific perspective, but right now also with an actual use case. So we would like to see how far we can bend Ceph into a cold storage or into an archival store. And for this we actually defined a master thesis. So Marcel Lauhoff is right now writing a master thesis with the topic basically how can we cool down Ceph. And we have some ideas how to do this, what could be done there, and so basically we would like to see what you think of the ideas, if you think some of them could be doable, if they are interesting. Maybe you also have some interesting questions that could go into this master thesis. And basically this is what this talk will be about.
Cool, okay.
So basically this is more or less a continuation. So in the last development submit, there was from the guys from HGST, there was this first approach. They discussed how can we redefine a tier to make it more silent. So basically the biggest problem is that a lot of data is moving around, which is nice. If things are getting rebalanced, we get new posts in there, everything is rebalanced. But the question for us would be like, how can we do or create a new tier or something that basically the least amount of data is moved. So put a file on an OSD once, and then in the best case, it will never ever move again until it is deleted. So we have some ideas, and maybe Marcel, if you would like to continue here from what you think.
Unmute.
Better?
Yep. Yep.
Okay. Well, we defined some ideas we thought we need for cold storage in Ceph. The first is we always came back to we need some kind of placement that is energy aware, and we thought of can we add like a bucket type that knows about how OSDs are powered up or powered down. And maybe based on a discussion I had with Loic at the Ceph Days in Paris, why not maybe power down based on the time? For example, if you have like 3 OSDs, assign a weight to one of them that is that basically prevents data from getting there. And do that like for an hour and then switch to the next, so that the OSD has like time to cool down or something. Well, I think it is quite doable, but I'm not sure how to get like this side effect data into the bucket choose functions.
Right. So I think in that kind of situation where you're basically cycling through, you have like the 3 OSDs that have the data, and you're just like, or however many, and you're cycling which ones are turned off and which ones are turned on. The idea would be that you would have like 1 off out of 2, or like 2 off out of 3, something like that.
Yeah, something.
I think it's going to be simpler if you do it not in the crush layer, but just above that in the OSD map. So the way that mapping currently works is crush spits out the set of OSDs that should store the data, and then we filter out all the OSDs that are currently down, and we get the so-called acting set, which are the ones that are currently sort of acting ones that are actually doing the work, and those are the ones that peer and actually do the writes. And so the down filtering happens after crush. So I think in this situation we could do the same sort of thing. Like, in fact, I'm not sure in the simple case of just powering down OSDs that it's not really that different than the OSD just being down. Like, you literally could just turn off the rack.
I have one more question here. So this would mean if we power up and down disks a lot, and for every disk we have one OSD, this would mean for every power up and power down, we would change the crush map and push it out to basically the whole cluster.
You would change the OSD map.
Much overhead?
You would change the OSD map, which is that, like 100K structure that describes who's up and who's down. But that's going to have to change no matter what, so that the clients know who to talk to and who's up and who's down. It's a small amount of data.
Like 10,000 disks which are going up and down again. This is basically a lot of OSD traffic, so OSD map change traffic, isn't it?
Yeah. Yep. And you'll have a very small trickle of IO that's sort of tracking that state.
Okay.
But I don't know that we can get around that, because you need to know who has the data, right? And the OSD map is the way that you represent that.
Mm-hmm.
So I think the interesting part for me is that it's not, you want to distinguish between an OSD that's deliberately powered down and one that is actually just down because you don't know why, like it failed or because it's turned off or something like that, right?
Yeah, basically,
we talked a little bit about this. Sorry?
But yeah, basically to exclude them from being an active target for writes.
Mm-hmm. Right. Yeah. Yeah, I mean, I guess you could have it be a function of time if you had a stable clock source, but I'm not sure that you do. So I think you have to actually publish OSD map updates that say that. I think that's going to be the simplest model.
Okay.
So I've been listening to this and I'm a little confused. Is there some reason that it actually needs to change the crush algorithms at all? Or couldn't these just be that we have like OSDs that are down for 6 hours and then they come back up?
Yeah.
Oh, okay. Sorry.
That's what I was suggesting. Yeah.
Okay. Sorry.
Right.
I guess I missed it.
Yep. So
the next question would be in the pad we have something like 1.3, like the crush rules. There are some like this sort of a linear fill or this distribution strategies. How complex is so? Some time ago I read something about making them more flexible or adding some plugin functionality into it. Is there some possibility to get more functions into these crush rules? Maybe this.
Yeah, I mean, we can. Yes, I mean, yeah, it definitely can. I mean, it's sort of designed to be functionally modular, I guess. So the rules have steps that you can sort of add new operation types, and we do that periodically. We have 4 bucket types that we define right now, but you could easily define new ones. There's a little bit of a compatibility thing where you have to make sure that the whole cluster understands the new features that you add to it. But we've done that several times now, so it's pretty well-worn territory. So I think if there are alternative mapping schemes that we want to pursue, then definitely. But that being the case, I think that the stuff where you're not actually changing your notion of where the data should be stored, but sort of modulating that with whether it's up or down and whether you're writing to it at this particular moment, those types of filtering steps can be done one step above without actually modifying core crush.
The next question would be how much intelligence can you get into these rules? So in the pad we have a 0.5 which is called mark data. So basically, if as a client, if I would like to build an archive, sometimes I exactly know how hot or cold the data that I put into the Ceph cluster are, and maybe I can somehow tag them. Maybe I have blue data and red data and yellow data or something. Is there any chance to get those tags, basically maybe as a system attribute or an object attribute that is written by the client? Can those somehow go into such a decision where Like map all the blue tagged files to object stores with, I don't know, IDs 1 to 10. Something
so,
like.
So you can certainly
how
tag
far could
objects. You can name them, you can tag them, you can do all those things. That doesn't propagate all the way to crush though, because crush isn't actually placing individual objects, it's placing placement groups. So you have a logical pool, that's the sort of logical collection of objects that's sharded randomly, basically spraying all the objects into different placement groups using a hash function. And then it's the placement group that crush is deciding where to store. So I think that the way that you would approach this generally would be that if you have a blue object, you put it in the blue pool. And if you have a red object, you put it in the red pool. Or you feed that information, you put it all in one pool, and you give that information to Rados, and Rados uses that to make a tiering decision. And it says, I'm going to actually just make this object a pointer that points off to the blue pool for this particular object because I think it's going to be cold. Which would rely, and I think that type of redirect would rely on some version of the redirect design that we kicked around, I think in the Emperor timeframe, but we didn't ever implement. We've only implemented the cache tiering so far. But I think probably having sort of a generic way to indicate that this object is cold and is unlikely to be modified ever again, or is warm. I do expect further updates. Having a generic way to communicate that down the stack would sort of help inform all of those tiering decisions, regardless of whether it's this or something else.
Okay. This would bring us to like point 2, the object stubs and links to external storage. So I think you talked about this earlier today. I missed that one. What is this current state? Is it like implemented? Will it be implemented? Could you give me the short?
Yeah, that was what I was just talking about. The redirects. We talked about it during that summit, and we haven't done anything with it since. So we haven't implemented it. So the original idea was to have two different types of tiering. One where you have your base pool where the data is stored, and you put a cache above it that sort of has a subset of the data that happens to be hot, and your IO hits the cache. And that's the one we implemented. And then that blueprint is about having a second tier that's colder than the base tier, where you just have a pointer where the object would normally be stored that points off somewhere else. And that one is, it's not implemented. We haven't gotten there yet. I think there are a host of applications for it. So one would be something you mentioned a couple, using your cold RAID scheme, or it could point off to a different Rados pool. It could point to, the cloud. It could point anywhere, right? As long as there's a way that Rados can sort of get input from that other object store. It's not currently a priority, I think, because I think the cache tiering is capturing sort of most of the tiering use cases that we're looking at right now. I think, but I think we definitely like to see something like that eventually, because it's going to open up a lot of possibilities.
Okay. Then we have, I think, Marcel, would you maybe introduce this archiving daemon idea?
Just back to the object redirects. I watched the Emperor video today. Do you think it's there you assume that it's links from Ceph to Ceph? I think. Do you think it's hard to generalize this to something Ceph to something else, like HTTP server? I don't know.
Right. So I took a quick look at that blueprint yesterday, and I don't think it's hard to generalize that. So I think the way that we originally wrote it up, I was assuming Ceph to Ceph, but the only thing that's stored on the cold object is just a flag that says I am linked from something else and a back pointer to like who linked to me, and that's just for like scrubbing consistency stuff. So it's not actually necessary for the correct operation of the system. So yeah, I don't think it would be hard to generalize. I think the only requirement would be that in order for it to work, obviously the OSD has to be able to do gets and puts to whatever it is that's on the backside.
Yeah, of course it is.
And probably tag it with some basic attributes that says, by the way, I'm a link. Yeah.
Okay. Yeah, it's kind of the key ingredient we thought of for cold storage. And the next point about the archiving daemon is actually we need this links for that. That thing is actually pretty short. I put some like pseudo Python code in the pad. I mean, it basically iterate over all stuff and decide on something and whether it's like cold. I don't know which metadata is actually in there. I didn't know if there's an A-time or something stored.
So this is almost exactly what the current tiering agent does. So with the cache tiering, there's a background thread that's called the tiering agent that does something like this. It iterates over objects and decides whether to demote them. It operates only on the cache tier. So it goes through the cached objects and decides whether to evict them. We don't explicitly store an A-time because that would mean doing a write on read.
Yeah.
But we approximate it using Bloom filters, and there's this whole infrastructure to basically guess what the A-time is with some sort of semi-certainty.
Okay,
but that's
it's
basically what it does.
It's basically already here. This archiving daemon.
Right.
Okay.
So basically, if you made the base, if the cold tier is the base tier, just a regular, maybe it's a erasure coded Rados pool, and the cache tier is like a hot replicated tier, then the cache tier is doing exactly this. There's something very close to it.
Okay.
So simply making a Rados pool that sort of satisfies your requirements for what a cold tier would do would get you most of this. So if we were able to make a Rados pool behave with powered down OSDs, for example, on a schedule, then I think it would work. Which I think it's sort of the So okay, so it sounds. I think there's sort of two directions that we can go with this. Directions. So the first direction would be making the external redirects work, and in that case, then you can push cold data off to anything else. It could be, Amazon Glacier. It could be, your Power Aware RAID thing. It could be anything. And that would be sort of one enabling piece. And by the way, we made it when we did the tiering stuff. We exposed all of the information about getting the Bloom filters to tell how hot or cold an object is and controlling the promote demote decision stuff. We exposed all that via librados, so you could actually write your tiering agent in Python. It turns out we embedded it in the OSD because it was faster and more efficient and simpler to do that. But those Rados calls exist, so you could write something else externally if you happen to know what should happen. But then the second direction is, I think, dealing with the power down situation, like how you turn off OSDs. And I think we talked a little bit about this in the session that you watched earlier last time. But this is the one that I'm actually sort of most interested in the shorter term, is figuring out what would make sense. Because I think there's sort of two ways to do it. And the thing I have in mind here is actually the HGST use case, where you actually have these disks that you literally want to power down individually, so the OSD would be turned off. And there are two ways to do it. One would be where you spin down the disk, but the processor host is still alive, so the OSD is still there, but it says I'm in a power down state, so don't send me any IO, or else I'll have to power up. And in that case, you would have to make, And alternatively, you would actually literally turn the thing down, and then you'd have to have some integration where you know how to send a special packet over the Ethernet or whatever to power it back up, which is that whole extra level of integration. But I think in both cases, the key thing would be giving Ceph an additional OSD state where it's aware that the OSD exists and it's presumed to be healthy, but it's turned off. And so it should avoid it unless it needs to, in which case it should turn it on. And I think that would be great to have something like that, but it sort of depends on what the expectations are and what the usage pattern is going to be. Because you can imagine a case where you have like 3 replicas and you just power down 2 of the replicas or 1 of the replicas just to incrementally cut down your power. Or you could imagine a state where you turn off the entire cluster for 20 hours of the day and then you turn it on for 4 hours and like ingest all the new data and do the reads and then power it off again. Something closer to what like the cold storage systems like Glacier are presumably doing. So what are you guys sort of targeting? I guess what's your use case you have in mind?
Yeah, actually I have a very concrete use case. This is still, as you said, this I've developed this 2-dimensional RAID. So basically I have a lot of disk drives in one enclosure. And on top I have in the end a file system which is somewhat smart where to put data. And this would be like point 4. What would be an interesting way how to integrate an OSD on top of either 120 individual disks that are smart in the way that they are always on, but some caching schema and so on and so forth. Basically, the system is always there, it's always available, but in the worst case, it will give you 10-second latency until you get the data. This is the actual use case there. But nevertheless, once data is written to the OSD, it should not be moved to the next OSD, even if, I don't know, assume the system has 100 disks, one server, 100 OSDs, or one OSD which somehow distributes the data to the 100 disks. So basically this additional state, if an OSD is on or off, is maybe not that important for me right now. Though for these HDSC disks, it's very important. I see that. For me, it would be more important to have more influence on how to put this mapping from a file, from an object to an OSD, that they will stick, that I have some control there, how to put them. Yeah, all blue files go to OSD1, all yellow files go to OSD2, something like that, or to some groups. This would be very, and then if I add another server, that nothing gets rebalanced, because rebalancing is good not for cold storage. No.
Right. Okay. So sorry, in the context of your 2-dimensional RAID, are you assuming that you would, on top of that, you layer the file system, and on top of that file system, then you would have a single OSD that sort of owns this big
this
chunk
might be
of
one exactly. This might be one implementation. Okay. The other implementation would be that I have 120 directories, which are internally more or less mapped to the disk drives. So this would be also a possibility.
Okay. So, and I think in that case, I guess the third direction to go into is to figure out how to avoid migrating data. And then I think there you just have this fundamental trade-off between having a metadata list ability to find where your object is stored versus having to store some metadata about where it goes, and then having a lookup of some sort before you find it. So I mean, in the simplest case.
Sorry.
Yeah. So I mean, the way that the current Rado stuff is structured, you can break things down by pool, and each pool can have its own scheme for mapping onto placing groups and placing groups onto OSDs. So right now that's all done through hashing a hash function in Crush, but you could presumably plug in something else. But the key thing is that right now it's all sort of defined in the OSD map. So this is a compact structure that is enough information to tell where the data is. So if you can come up with a way where knowing where that's enough information to find out where your object goes without having to move stuff, then that would work. But I think it's tricky because if you want to arbitrarily name your objects, then you can fill in like parts of the namespace that have already been written to a particular OSD, and you want to make them not go there. You want to make them go somewhere else. Like you have to sort of like name them based on when they were written, perhaps, and that sort of makes things different, right?
Mm-hmm.
So, I mean, are you thinking that you'd want to find a way to sort of solve that problem to make it time-based, or are you thinking that you would actually have an external metadata server that's sort of tracking where objects go?
I had the hope that this could be somehow solved with the crush map, some magic in there. So having an external metadata server, I think this is not an option.
Well, if you name things based on when they were written with some stability, then you could say that the objects written in this time. Then you could have a compact representation that says like this slice of time is written to this device and this slice of time is written to that device, and that could be relatively compact in that it's like the size is on the order of the number of devices, and so it's not going to sort of expand the size of the OSD map by a order of magnitude or anything like that. And that would work, right? Or you could be clever where you have like this longer time period. I was hashing over, these 12 devices that happened to be in my cluster at that time until they filled up, and then you sort of checkpoint it, and then you have some other thing. Does that make sense?
I have the feeling that I understand what you're talking about.
Yeah. Okay. There was a.
But one question to that. This would mean that I have to have the name of an object. This is the one that goes into. So if I have the power of naming the object right, this is fine. But
if you
could not plug it into a Ceph maybe this would be problematic.
Right.
I think.
Right. But if this is intended for cold storage, then you will be probably not putting things directly in this pool, but you'll be putting it in a different Rados tier and then using the redirects to point off into this other thing. And so in that situation, you can sort of arbitrarily name your object at that point, right? Because you you have to have a pointer that you can control the name of the thing that it points to. But if you have that pointer in where the object would normally have been stored if it were hot, then you can sort of get that.
So when exactly did you want to implement these steps? Okay.
Yeah. Well, I mean, you can sort of, for the purposes of like figuring out how this would work, you can just assume that you have control over naming the object, or less control over naming the object, right? So there's a portion of the object that you don't control, or whatever. Yeah. However you want to structure it. Like maybe you ask the system, give me an object name, or maybe you say, maybe it's a combination of the part that you don't control that the system provides and the part that you do control. But I think the thing that you might look at that sounds like it might line up with what you're trying to do. The crush list buckets are based off of the original rush algorithm, which was based on this idea that when you're deploying a big cluster, you sort of deploy it in stages. So I would first deploy my first 100 disks, and I would hash across them, and then at some point those would fill up, and I'd deploy my second chunk. And so the way that the hashing algorithm, it was basically an exception that says this percentage of the objects are stored in the new stuff, and if they weren't stored there, then they go to the old stuff. And then you have the third thing. And so it's basically a list. Is it in the newest category? If not, is it in the second newest category? If not, is it in the third newest category? And I think that type of scheme could be used with this sort of time slicing idea, where you say, during this period of time, I had these devices and they were sort of randomly scattered across them. And then later they filled up, or I deployed whatever, some event happened. And then I had sort of the new view of things where I stored them in the new place. and then and so on. But eventually you're going to have the situation where you want to decommission the old thing, and so you'll have to say like 10% of what used to be there is now, got shoveled back into the new thing or something. I think you could have some sort of layered exception type approach to defining how they're. That makes, I'm sort of waving my hands here, but I think that general idea could probably be applied. That in context with the idea of slicing things up over time periods, I think would get you your compact representation.
For the time slicing, when I have control, assuming that we have these stubs, would it be possible to also integrate object metadata there? So again, this as a user, I mark my file as blue with a user type blue, and also put the blue into the hash function.
I think that you would. I mean, I think you could do that. You could just make it part of the name, even, right?
Yeah, exactly.
But I think it would be probably more. My gut tells me it'd be more useful to put that sort of at the next layer up. And so if you consider your cluster has a bunch of different logical pools, and one pool is this like ultra cold, and one's warm, and one's hot, or whatever. But the application is sort of talking to the overall data collection and marking your object, and then the system is deciding where to put it, which pool to put it in based on the temperature. I think then that gives the system more flexibility, because you might have a really cold thing that decides to cache because for some reason you're reading it a lot, or you might have a data set. I think maybe more importantly, you might have a situation where you have this data set where you're just ingesting a bunch of data and you want to just mark it with hot, medium, cold. But how it's stored on the back end might change over time. And so initially it might all be just stored on disk, but maybe you buy this fancy new cold storage thing, and then you look at the existing metadata, and you can sort of how you map that basically onto the low level storage backend. You could define later at a different point in time.
Okay.
If that makes sense. But I think it'd be a little bit more flexible to do it one layer up.
Yeah, sounds good. Okay.
Yeah.
So I think we have a lot of work for the master see this.
Yeah. Okay.
And for everything that might come out of that.
Yeah. Okay. Okay.
So how much do we have time left, or are we finished? I'm not exactly sure.
Yeah, we're just about at the end of the time slot here, but if you had a few other things to wrap up, we could probably do that.
Yeah, I mean, we can.
It'll probably be a little short.
Yeah. You can. Yeah. You can go over if you want. If you have more questions or whatever.
So actually, I learned a lot. Thank you for that. I don't know, Marcel, maybe you have some more.
No, not really. I mean, it all comes down to we need object redirects to do anything, I guess.
Yeah, but I think the case for having object redirects will be bolstered by having a good thing to redirect to. So I think you could, for the purposes at least of your master's thing, you could probably just assume that a capability like that exists, and then and figure out how you would leverage that, like how you would structure a logical pool that sort of does the thing that you're talking about.
What do you think? How much work is it to actually implement that?
I'm always the wrong person to ask about that. So we had sort of two pieces of the tiering picture that we originally proposed. One was the cache tier that sort of logically sits in front, and then the cold tier that we redirect to that sits below. And the cold tier was definitely more complicated in terms of all the interactions that would happen and promoting and handling the races and so forth. So we implemented the cache tier one, and it took like at least twice as long as we thought it would, to be generous. And so I think the demotion one would be more complicated. It's possible that we could simplify it somewhat from what we originally proposed, but I have to look at the blueprint in more detail. I think it's not trivial, basically.
On the upside, a lot of it is well spec'd out, and we have sort of at least prototype redirect functionality built into the messenger, or not in the messenger, but in terms of like the messages and
the client stuff is sorted out.
Yeah.
A lot of the pieces that it fits into have already been sorted out, so it's like it's just the sort of the core redirect stuff that needs to be done. So I would let's see if you look at the blueprint for, if I can find it, the original one that you linked to actually. See, we actually have persistent states for indicating whether we were promoting. I don't actually know if we need all of that, do we?
Well, this is how we were dealing with races.
Yeah, I have to reread this whole thing to see if it's actually all that's necessary or not. Because we don't allow writes on the back end, similar to the cache tier.
Well,
in this case,
no, that was going to be an option.
Oh, I see. So originally we were imagining that you could actually write to the back end directly.
Yeah.
If we changed this so that the really cold tier was only read only, which I'm guessing is probably what you would expect. Is that right? You probably wouldn't expect to modify this data once it's in your cold layer.
Nope.
Yeah. So that would probably simplify it. Yeah, because I think that would simplify it quite a bit actually. Because we were trying to deal with being able to write to the back end. Yeah, okay. Yeah, all right. So we'll have to revisit this. But I think it's simpler than we thought.
Okay. So maybe you think it could be possible to implement it in a prototypical way for the CSIS, maybe?
Yeah, it depends on how much. It's a non-trivial amount of coding. So it depends on how sort of deep into the stuff you want to get. Again, I think that you would have more get more mileage out of focusing just on the cold tier and assume that the redirect stuff exists and then implement that, because that's probably where most of the interesting stuff happens. And this is just sort of mechanics of integrating everything into the current structure.
Okay, yeah.
Yeah.
So,
and your end goal is to write a paper and a thesis, and not necessarily to get something that you can deploy. So you don't necessarily have to have that all the. Although it's certainly great to have code at the end, but probably not what I should be saying as the string person. But yeah.
Okay.
Cool.
Okay.
So,
How about wrap that up?
I think so.
Excellent.